Okay, today we're going to go over the CC1 8.3.2 review and preview. As always, remember, if you have more questions than I can help you with on this video, make sure that you are coming in to talk to me. Okay, problem 101. A train travels at an average rate of 40 miles per hour and travels for 110 miles. Using what you know about distance, rate, and time, write an equation for the situation. Be sure to define your variable. Okay, so we know that distance equals rate times time. Okay, so when I define my variable, D equals distance, R equals rate, T equals time. Okay, so my distance. The train traveled for 110 miles. I'm not going to use this yet. I'm just going over what I know. I know that my train travels at 40 miles per hour. Okay, so the distance is going to equal 40 times however much time. I just want an equation. I have to solve my equation in part B. In part A, it's not asking me to solve yet. I'm just writing an equation. Part B says use your equation to determine how long it will take the train to travel the 110 miles. The total distance is 110 miles equals my 40 miles per hour times time. Now I have to figure out what does T equal? How much time has passed? So in order to do that, I have to do 110 divided by 40. That's going to get me what T equals. 110 divided by 40 is 2 75/100ths, which is also 2 hours. It's 3/4 of an hour, so in 45 minutes. So when I ask what T equals, it's 2 75/100ths hours, or 2 hours and 45 minutes. Okay, problem 102, the graph represents this situation. Kara jogs every morning. After 30 minutes, she has run 3.5 miles. How are we representing Kara's speed on the graph? It's represented by the steepness of the line. So the speed is the steepness of the line. I'm going to try to turn my camera so it's not quite at an angle. It's because I write with my paper sideways. Okay, we need to write a rule for Kara's distance if T represents the number of hours. T is time. T represents the number of hours. Okay, so in 1 hour, I have to figure out how many miles does she go. It's already blocked for me. She goes 7 miles in 1 hour. Okay, so her distance, if it's rate times time, the rate that she's going at is 7 miles per hour. And we don't know how much time she's running for. Okay. Part C, if Kara continues to run at this rate, predict how far she will run in 4 hours. So distance equals her rate of 7 miles per hour times the amount of time that she's going to be running, 4 hours. So her distance is going to be 28 miles. On the other side, we have some expressions that we need to write the equivalent expressions for. We're rewriting the expression with an equivalent expression and then evaluating the expression when x equals 3 and y equals 1. Okay, so I'm rewriting it first. So I'm going to use the distributive property here. I have 3x times 5y. 3 times 5 is 15. And then I have x and y there. X times y is just 15 times x times y. Minus 3x times 4. 3 times 4 is 12. And I have my x. Okay, I rewrote it. Now I want to evaluate it. So 15 times 3 times 1 minus 12 times 3. 15 times 3 is 45 minus 36. 45 minus 36 is 9. So the answer is 9. I'm going to do the same thing here. I'm going to find the greatest common factor between 7y squared and 28y. 7 goes into both 7 and 28. I'm left with y squared, 1y squared. And 28 divided by 7 is 4, and I still have the y. When I'm finding my greatest common factor using this ladder method, I can keep going. I can actually say, well, y squared is y times y, so I can divide or factor out a y. So that leaves me with 1y and 4. My greatest common factor is 7y. That is what goes on the outside of my parentheses. On the inside of my parentheses, I have y plus 4. Now I can go through and substitute. So 7 times 1 times 1 plus 4. 7 times 5 is 35. Okay, for this one. If I'm going to rewrite it, I could combine like terms. I can say, okay, I have x minus 1 plus, this plus is what gets distributed. So plus 4x minus 3. So x plus 4, so I have this term plus this term. So 1x plus 4x is 5x. And if I take negative 1 and subtract 3, I get negative 4. So 5 times 3 minus 4. 5 times 3 is 15 minus 4. That equals 11. Problem number 104, find the area of the figure below. I can do this a couple different ways. Remember, I can break this shape apart. I can either break it apart here or here. I want to break it into as few rectangles as possible. I generally break it apart here. Remember, you can't go the other way. You're going to get the same answer. Okay, to figure out the area of this rectangle down here, okay, I have to multiply 2 and 1/10 times 8 and 2/10. So I do that here. 2 times 1 is 2. 2 times 2 is 4. Put my placeholder. 8 times 1 is 8. 8 times 2 is 16. I add 2 plus 0, 8 plus 4, 6 plus 1, and a 1. And then I move my decimal 2 spots. So the area here is 17 and 22 hundredths. I have to do the same thing for this rectangle up here. I know one of my side lengths is 6. I don't know what this is until I do some subtraction. I have to do my 8 and 2/10. So this length here but I have to subtract that 4. 2 minus 0 is 2. 8 minus 4 is 4. It's 4 and 2/10. I can label it. I multiply that by the 6. 6 times 2 is 12. 6 times 4 is 24, plus 1 is 25. I move my decimal one place. So the area for this rectangle is 25 and 2/10 meters squared. For my area, I add them together. It's 25 and 2 meters squared plus 17 and 22 meters squared. 25 and 2/10 plus 17 and 22 hundredths. 2 plus 0 is 2. 2 plus 2 is 4. 5 plus 7 is 12. Carry my 1. 2 plus 1 is 3, plus 1 more is 4. Drop my decimal down. The area equals 42 and 42 hundredths meters squared. Problem 105. Draw figures 0, 4, and 5. Explain how you could know the number of dots in any figure if you knew the figure number. So what I need to look at is how is the figure growing? Okay, so if I look at figure 1 and I go to figure 2 and I say, okay, these are the ones that show up in figure 1. What did I add? I added 1, 2, 3, 4. So now I want to do the same thing. And to figure out how many I added in figure 3. Am I still adding 4? Oops, I circled the wrong one. Okay. I am adding 4 each time, which means that if I go down one figure, I take away those 4, so I'm left with just 1. So then it still is following my pattern. Figure 4, if I'm looking, I also notice figure 3, if I have my starting point, it's my starting point. I have 1, 2, 3 going out, 1, 2, 3 going to the right, 3 going down, 3 going to the left. If I go to figure 2, I have 2 going left, 2 up, 2 down, 2 to the right. So if I start with my original dot from figure 0, I should have 4 dots going up, 1, 2, 3, 4, 4 going to the right, 4 going down, and 4 going to the left. Figure 5, I'll have 5 going up. 2, 3, 4, 5. 5 going down. 1, 2, 3, 4, 5. To the right and to the left. Okay, so it's adding 4 each time. If I know the figure number, how am I going to figure out how many dots are in there? So if I know the figure number, I'm going to assign a variable. I'm going to say let x equal the figure number. I'm going to say, okay, x. I'm going to say, okay, I add 4 each time, so I'm going to check to see if I'm right before I write it down. If I take the figure number and I multiply it by the number of dots I add each time, so 2 times 4, I should have 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then I have 1 more, so I add 1. I'm going to see if it's true in figure 3. If I do 3 times 4 plus 1, I should have the same number of dots if I'm correct. I have 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12, 13. 3 times 4 is 12, plus 1 is 13. Okay, so I know I'm multiplying by 4. I'm adding 4 each time, but I started with 1 dot in figure 1. Okay, that's my expression or expression to find the number of dots in any figure. It's a horrible arrow. As always, if you have any questions, please feel free to come and talk to me.